Hello girls, I hope you're staying safe at home. Now in chemistry, we are going to start with a new chapter, that is atomic structure and chemical bonding. Okay. Now from long time back, attempts were made to know what was the smallest particle of matter. So the first idea was given by a Maharishi in India whose name was Kanada. Okay, that was almost in 6th century BC. According to him, he said that matter was made up of indestructible minute particles, small particles which could not be destroyed, and he called it Paramanus. Okay, now a Paramanu does not exist in a free state, and he said that it combines with other paramanus to form a bigger particle called anu. That means atoms does not exist in the free state, but it will combine with other atoms to form a bigger particle known as molecules. Okay, but later on, the first scientific theory about the structure of matter was given by John Dalton in 1808. So he considered atoms as indivisible particles, indestructible, indivisible, which cannot be divided. Okay, so which were the building blocks of matter? That is, these particles made up matter. Now, the existence of different types of matter is because of the different types of atoms that makes them up. So what did Dalton say about his atomic theory? He said, first, matter consists of very small and indivisible particles called atoms. Smallest particle, and they are indivisible, and they were known as atoms. And he also said that atoms could neither be created nor destroyed. The atoms of an element are same, alike in all respects, but they differ from the atoms of other elements. Now, for example, if we are talking about the atom of, say, oxygen, so two oxygen atoms makes up the oxygen gas. So both the oxygen atoms are same, but they are different from nitrogen atoms. Okay, so atoms of an element, they combine in small numbers to form molecules. Like O2 forms oxygen, two atoms of oxygen. O3, three atoms of oxygen come together to form ozone. Okay, so small numbers, small numbers of atoms, they come together to form molecules. And next he also said that atoms of one element combine with atoms of another element in a simple ratio, and I think you know what will be formed. Compound will be formed. Okay, that is, if two atoms of hydrogen combines with one atom of oxygen, it will form a compound water. Atoms are the smallest units of matter which can take part in a chemical reaction. So in a chemical reaction, the molecules breaks up into atoms, and it is these atoms which take part in the chemical reaction. Okay, and the latest research on atoms prove that most of Dalton's atomic theory, whatever he said, are incorrect, except that atoms take part in a chemical reaction. Of course, Dalton, he said this in 1808. That was a long time back. Since then, there has been lots of research going on. So now, one of the first indication that atoms consist of subatomic particles. So he said that matter was made up of smallest particle known as atoms. So beyond that, atom could not be divided. But later what was found out? Atoms still were made up of smaller particles, subatomic particles, and they are made up of charged particles. Charged particles means positive charge, negative charge. Okay, and this was put forward by the study of static electricity. Static means electricity which does not move. That is, charge is made at a certain point. Like if you take a ruler, rub it on your hair and try to attract small bits and pieces of paper, it will attract, if you see. So that is static electricity, electricity at a point which is not flowing. Okay, and of course the conditions under which electricity is conducted by different substances. So it was in 1833 Faraday showed that the flow of electricity is due to the flow of charged particles. That means atoms were still made up of smaller parts. Now GJ Stoney, that was later again in 1874, he suggested the name electron for this electrical particle. That is the particle which carried electric current. He gave the name electron. But finally, it was J.J. Thomson who showed the existence of these charged particles. Previously they were just like, saying, okay, this is there, this is happening, electrons are there, they are charged particles. They had not yet seen the existence. So it was J.J. Thomson who showed the existence of these charged particles, and electrons were discovered, which were negatively charged particles. So electrons are negatively charged particles. Then later, E. Goldstein, a German scientist, he discovered the protons. Protons are positively charged particles in an atom. And later on, James Chadwick, he discovered neutrons. Neutrons did not have any charge. So the electrons, protons and neutrons are called the fundamental particles of an atom. That means an atom is made up of electrons, protons and neutrons. Okay, so these particles are the building blocks of all atoms of an element. That means the atoms are made up of electrons, protons and neutrons. I think all of you know what an element is. So you know, when you define an element, you define it as a pure substance that can neither be decomposed into nor formed from simple substances by ordinary physical or chemical methods. That means an element is made up of a single type of atom. Okay. Now, for example, carbon is an element. Why? Because it cannot be split up into two or more simpler substances by ordinary methods like heating or breaking or passing electricity through it. Okay, and another thing, children, you must remember is the term radioactivity. Okay, it is the processes of radioactive decay and high energy nuclear reaction which can transfer one elementary substance into another. Now you will be learning about radioactivity in detail in the higher classes. Now, what is an atom? An atom is the smallest particle of an element that exhibits all the properties of that element. Exhibits means it shows all the properties of that element. One atom. Supposing oxygen, if you take out the gas, for example, O2. Now, if you break up oxygen into its atom, that is O, that means that one atom of oxygen will show all the properties of oxygen. Okay, it may or may not exist independently but take part in every chemical reaction. So if there is just one O, what does it mean? Can it exist as one atom of oxygen? No, it cannot, because two must come together to form the oxygen gas, or three atoms must come together to form ozone gas. But again, in the case of carbon, what is the formula? C. Sodium, Na. That is just one atom, so it can exist independently. So what happens when we are talking about the atom? It can exist independently to form an element, or it may not exist independently, but it will take part in any chemical reaction. Okay, now take a small piece of zinc. Zinc, you know, is a metal, and you break it up into very tiny pieces. All these all these small pieces of zinc will show the properties of zinc. Now, if you keep on grinding them, and then you change it into powder, very thin powder, it will still show the properties of zinc. But there will come a stage when the particles cannot be divided further. You're keeping on making it smaller and smaller and smaller and smaller. So when you cannot break it up further, then where have you reached? You have reached to an atom of zinc. So these indivisible particles which you cannot divide further are the atoms of zinc. So in other words, we can say that atom is the smallest possible unit of an element. Okay, now how was electron or the negative particle discovered? Okay, it is a nice story. There was this British scientist whose name was William Crook. he noted that gases are actually poor conductors of electricity, that gases did not conduct electricity. But when he used a very high voltage, about 10,000 volts, charge from an induction coil, and he applied it to tubes filled with gases. He had filled tubes with gases and he gave a very high voltage at very low pressure. Pressure was only 0.01 millimeter of mercury. Actually, it is 760 millimeter of mercury, the normal atmospheric pressure. So what happened then? Magic. The gases became very good conductors of electricity. Normally gases do not conduct electricity. And then it began to flow from cathode to the anode. Cathode is the negative terminal and anode is the positive part, which is connected to the positive terminal of the battery, and cathode is connected to the negative terminal of the battery. Remember, A is the anode. A means add, that means it is positive. Okay, so in the form of rays, he saw that the gases became very good conductors and they started to flow from negative to positive, that is from cathode to anode, in the form of rays. Okay, now since these rays came from, you can see, from the negative plate, that is the cathode, that is the cathode, and it traveled from the cathode towards the anode. So they were known as cathode rays. So William called it cathode rays. Now, later, again, the same experiment was done by J.J. Thomson. He started studying the characteristics and the constituents of the cathode rays. Okay, and he made an apparatus which is known as a discharge tube or a cathode ray tube. So here you can see this is the tube. Okay, then pressure is very less, 0.01 millimeter of mercury inside this tube. Okay, and then towards the vacuum pump, that is, which is pulling the gas inside. And then this is the plate, you can see, which is connected to the negative terminal of the battery. So this is the cathode. And this is the plate which is connected to the positive terminal. So this is the anode. Remember, A for add, and it is connected to the positive terminal of the battery. So this was, the wires was connected to the induction coil from both the terminals of the battery. Now, so I have explained a discharge tube, hard glass tube, which is fitted with two metal plates, cathode and anode. Collectively, they are known as electrodes. Okay, and one which is connected to the positive terminal is the anode, and the one which is connected to the negative terminal is the cathode. Then it has a side tube through which gases can be pumped out, which is leading to the vacuum pump by using, and it creates a vacuum, and then the gases will be pulled in. So when electrical discharge of 10,000 volts is passed through the gases at very low temperature, cathode rays are produced. So the cathode rays were seen. So the properties of cathode rays was studied by J.J. Thomson. So what did he find out? He found out that they travel from the negative cathode to the anode, the positive, in straight lines. Okay, and they cause a greenish yellow fluorescence, a fluorescent yellow color, greenish yellow color on a soda glass screen placed in the tube. A soda glass screen was placed on the tube and it glowed. The soda glass screen glowed into a greenish yellow fluorescent color. Okay, they are affected by electric field. That is, they are inflected towards the positive field. That is, they are moving towards the positive field, and deflected from the negative field means they are moving away from the negative. So that means they carry negative charge, because the opposite attract and similar will reflect. And next, what was seen was, when a beam of cathode ray was made to fall on a hard metallic target. Tungsten is a metal, very hard metal. X-rays were produced. Okay, and they even penetrated through matter. They just went right through matter, and they caused ionization of the gas through which they pass. That is, the gases through which they pass, they also turned into ions. So the ratio of the charge, which is written as E, to the mass, which is written as m, of the particles which made the cathode rays always remains the same. That is, E divided by m always gave 1.76 into 10 to the power of 11 coulomb per kg. Like, you could take any gas, irrespective of the nature of the gas taken and of the metal forming the cathode. Always E by m always gave 1.76 into 10 to the power of 11 coulomb per kg. Okay. Now next, they produce the shadow of an opaque object placed in their path, and they make a light paddle wheel rotate. Okay, so a paddle wheel is like, like a fan. Very light paddle wheel, like fan is there, and if it was placed on the path, it started rotating. That means it had some, force. So finally, what did Thomson conclude? He concluded that cathode rays were made up of negatively charged particles. Now they are known as electrons. Okay, and these negatively charged particles are an integral main part of all atoms. It is present in all atoms. And electrons have both definite mass, it has definite electric charge, that is negative charge, both of which are independent of the nature of the gas in the discharge tube. You can take any gas in the discharge tube. So finally, the properties of the electrons were taken up, and it was more or less, you can say, taken up, and then it was studied. First, electrons from all sources are alike. They are the same. They have the same mass. They are a constituent part of all atoms. They are present in all atoms. The mass of an electron is 1 by 1837. The mass of hydrogen atom. When it is combined with hydrogen atom, they found out it was 1 by 1887, the mass of hydrogen atom. And an electron carries unit negative charge. Unit means 1, okay, of magnitude minus 1.602 into 10 to the power of minus 19 coulomb. The electron is very, very small. Its radius, radius means, if you take the radius and draw a circle, that is your radius, it's less than 1 into 10 to the power of minus 15 meter. So finally, you can define electron as a subatomic particle having a unit negative charge and a mass equal to 1 by 1837 of hydrogen atom. Okay, and this is the symbol that is used. And the superscript, that is at the top 0, is the mass, and the subscript minus 1 is the electrical charge. So atoms are actually electrically neutral. It does not show any charge. So what was concluded? It was concluded that in addition to the negative charge electrons just discovered, particles that are positively charged should also be present, so that it cuts off the charge and the atom becomes electrically neutral, so that the total negative charge of the electron is equal to the positive charge. So this realization, these chemists, they started realizing that an atom cannot be negatively charged only, so they started looking further for positively charged particles, and then later it was discovered that the protons were discovered. So when a high voltage current is passed through a gas taken in a discharge tube, electrical energy breaks up the atoms of the gas into negatively charged particles, electrons, and positively charged particle, protons. So we will stop here, children. For your assignment this week, I want you to draw the discharge tube with flowing electrons, that is figure 4.1, and write down the properties of cathode rays and electrons. Till then, children, stay safe. God bless you.